Good morning, friends, and welcome to our live broadcast. Today's lesson is going to be on proving trigonometric identities. We're going to look at a couple different cases as we go along today. We're going to start officially at 10, which is in about 5 minutes. So let me give you a problem to work on while we're waiting for a few other people to join us at the top of the hour. So see if you can prove the following. Cos x over secant x plus tangent x equals 1 minus sine x. So I'll give you some hints as you're getting started with this. We're going to go ahead and convert everything to sines and cosines, and then do the various algebraic manipulation we need to do to get that to equal 1 minus sine x. So again, I'll give you the next couple minutes to work on that, and then we'll get started officially here shortly. So just another hint with my approach, I like to start with one of the two sides, more often than not the left-hand side, because that tends to be more complicated. Then I write left-hand side equals what the left-hand side equals. I'm going to simplify and have a string of equations, equals, 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 to get it to 1 minus sine x. So see if you can make that work. About 2 minutes until 10 o'clock when we'll start officially. Okay, well, good morning. This is Bob Capetta from the University of Illinois at Chicago. And today's lecture is going to focus on trigonometric identities. We're going to begin by proving some, and then we're going to develop and use some very important identities a little later. So I'm starting with the following question asking you to prove. Show that cosine x divided by secant x plus tangent x equals 1 minus sine x. And one of our strategies is going to be to convert everything to sines and cosines. So what I'll get upstairs is cos x. Secant x is 1 divided by cosine x. Tangent of x is sine x divided by cosine x. And the thing is, when you're proving identities, there are several possible strategies that you can use. Here's what I see. On the top, I see cosine x. On the bottom, we now have a common denominator. We have cosine x on the bottom. And I have 1 plus sine x on top. So that's what I see here. And now I have cosine x divided by 1 plus sine x over cosine x. So I'm going to go ahead and write it with that division symbol. I'll say cosine x divided by 1 plus sine x over cos x. And we're dealing with fractions, so let's make cosine x over 1. Looking at this then, we can say that this is cosine x over 1 times cosine x over 1 plus sine x. Multiplying across, cosine x times cosine x is cosine squared x. 1 times 1 plus sine x is 1 plus sine x. Now we have to do a little bit of analysis. Upstairs I have cosine squared x. I want to rewrite cosine squared x as something else. So I'm leaving the bottom as 1 plus sine x, but I want to rewrite cosine squared in another way if I can. And I'm going to do that by taking a look at the Pythagorean identity. So what do we know about the Pythagorean identity? Cos squared theta plus sine squared theta is 1, right? That's our most important identity. I have cos squared x here, so certainly I could rewrite theta with x. I could say cos squared x plus sine squared x is 1. And then what is cos squared x? Solving for cos squared x, subtracting sine squared x from both sides. I get cos squared x is 1 minus sine squared x. And I can replace cos squared x with 1 minus sine squared x. That is one of our Pythagorean identities. So let's take a look at what we have and what we're trying to get. My right-hand side is supposed to be 1 minus sine x, and we're awfully close here. We're awfully close to 1 minus sine x. What I have to do is I have to factor 1 minus sine squared x. How do I factor 1 minus sine squared x? Well, you may recognize that that's a squared minus b squared from algebra. So that's a minus b times a plus b. So 1 minus sine squared x is a minus b, 1 minus sine x, times 1 plus sine x. That's how that would factor, all divided by 1 plus sine x. And seeing that, we can recognize that the 1 plus sine x is cancel, gone, gone. And the result is 1 minus sine x, which was our right-hand side. Remember, that's what we asked to prove. We asked to prove cos x over sec x plus tan x is 1 minus sine x. Left-hand side equals this, 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 which equals the right-hand side. So that finishes the problem for us. We've gone through a string of equal signs to show that the left-hand side equals the right-hand side, and that is how we prove that identity. Now, there are multiple ways to do that. That is not the only way to prove that identity, but I think that is certainly one of the more efficient strategies. I want to do a couple more of these if I can. So let me put the next one up, and I'll give you a couple seconds to think about it. So here we go. We'd like to prove sine to the fourth of theta minus cos to the fourth of theta equals sine squared theta minus cos squared theta. And how are we going to do this? Well, the hint here is to use that same rule for factoring that we used in the last problem, namely a squared minus b squared is a minus b times a plus b. Can you see that? Maybe you can see that. If not, we can go ahead and do our factor box if that's something you like to use. And we can say our first term is sine to the fourth of theta. Our last term is negative cos to the fourth of theta. And how do we build sine to the fourth of theta? What times what? Well, that would be sine squared theta times sine squared theta. How do we build negative cos to the fourth of theta? That would be negative cos squared theta. Whoops. Times positive cos squared theta, where the middle term is 0. So when I multiply this together, negative cos squared times sine squared is negative sine squared theta, cos squared theta, and then sine squared theta plus cos squared theta here. But those guys cancel each other out, and I get sine to the fourth minus cos to the fourth. So my left-hand side here, which is sine to the fourth theta minus cos to the fourth theta, can be factored, again, using this a minus b times a plus b, or this strategy, into sine squared theta minus cos squared theta times sine squared theta plus cos squared theta. All right, so let's go ahead and write our proof. For our proof, I want to start with the left-hand side. I want a string of equal signs to go ahead and get me to the other side. So left-hand side, sine to the fourth of theta minus cos to the fourth of theta. Well, what did I say that equals? We did our work up here and said that equals sine squared theta minus cos squared theta times sine squared theta plus cos squared theta. But what do we notice? What do we notice? Sine squared theta plus cosine squared theta, that is our Pythagorean identity. This thing is 1. So we're essentially finished. What we get here now is we get sine squared theta minus cos squared theta times 1, which equals sine squared theta minus cos squared theta, which is the right-hand side. Remember, original question, sine to the fourth minus cos to the fourth equals sine squared minus cos squared. That's what we have. We've done that successfully, and that one is completed. Okay, I want to do one more proof of a trig identity before we jump into today's special identities. So I'll give you a chance to think about this one. We are going to look at the following. We want to prove 1 plus sine theta over 1 minus sine theta equals cosec theta plus 1 over cosec theta minus 1. This time, I think I'm going to do it differently. Rather than starting on the left-hand side, I'm going to start on the right-hand side. Normally speaking, we want to have the more complicated side first. So I'm going to try it that way and see if I can get where I'm going. I'll say right-hand side here is cosec theta plus 1 over cosec theta minus 1. Now, hopefully we remember our basic facts. We know that cosec theta is 1 over sine theta. So then I'm able to go ahead and rewrite this. Cosec theta now is 1 over sine theta plus 1 divided by cosec theta 1 over sine theta minus 1. Well, what do I want to do now? I want to multiply top and bottom by sine theta. Let me show you what I mean. So this is going to equal 1 over sine theta plus 1 over 1 over sine theta minus 1. And I'm going to multiply the top by sine theta to clear the denominator. I'm going to multiply the bottom by sine theta to clear the denominator. Algebra here is a little challenging, but let's see if we can make sense out of this. 1 over sine theta times sine theta when I distribute this way, plus 1 times sine theta, which is just sine theta. On the bottom, 1 over sine theta times sine theta, minus 1 times sine theta, which is just sine theta. So what happens here, 1 over sine theta times sine theta is 1. So on the top, I have 1 plus sine theta. On the bottom, what do I have? I have 1 over sine theta times sine theta. I have 1 minus sine theta. And I believe that was the left-hand side of our original question. You see our left-hand side, 1 plus sine theta over 1 minus sine theta. That was our left-hand side. So that will equal left-hand side. Once that's done, the trig identity is proved, and we'll go ahead and put a smiley face. So these are not simple problems to do. And after watching this video, you should try it again. So my suggestion is we've done, what, 3 of these identities in this discussion today. So copy them down as soon as you're done watching this video and try to solve them yourself. If you can, great, you'll learn something. If you can't, you have to study it. Watch the video again to make sure you're where you need to be. All right. Well, today, the main point of our lesson, our primary focus is going to be on the following identities. So we have sine and cosine sum identity. So we'll start with the following: sine of a plus b is sine a cos b, sine cos plus cos a sine b. So you'll notice for the sine function, the SIGN stay the same. Here's a plus here, there's a plus here. The same thing happens for sine of a minus b. Sine a cos b minus cos a sine b. Now, before you get too anxious, the standard policy in our course is to give you these complex identities on the exam so you don't have to memorize them. Although I have to say, I think there's some value in knowing them well because you may be using them in calculus and beyond. So that's the identities for sine. How about the identities for cosine? Cosine of a plus b, cos a cos b, minus sine a sine b. So you'll notice for cosine, the SIGNs change. Plus sign here, minus sign there. Same thing for cos a minus b is cos a cos b plus sine a sine b. So I have every intention of giving you these formulas come exam time here in a few weeks. So let's take a look at sine 2 theta, because this is a double angle identity. This is very important. This is one I do want you to memorize for calculus. 2 theta means theta plus theta. So if that's the case, A is theta and B is theta. So looking at the identity, that's sine theta cos theta plus cos theta sine theta. Putting them all together, then what does sine 2 theta equal? Sine theta cos theta plus cos theta sine theta, that's 2 sine theta cos theta. So I strongly recommend that you memorize that one. Sine 2 theta is 2 sine theta cos theta. It is very useful. Now let me go ahead and ask you guys to do cos of 2 theta. So try that, and if you have an answer, you can go ahead and write it in comments. So see if you can use the appropriate formula, this one here, to establish an identity for cos of 2 theta. I'll check the comments to see how well you're doing with that. So A is theta, B is theta. You want to generate a rule for cosine 2 theta. And there's actually multiple rules for cos of 2 theta that we could use. But let's see, we've got 38 people watching. Hopefully 1 or 2 can put the answer up. I can see if it's right. Okay, well, maybe our comments are not loading. So I will find out what's going on with that before the next time I go live. Cos of 2 theta is just going to be cosine of theta plus theta. Cos theta minus sine theta sine theta. So if that's the case, I'm going to have cosine 2 theta equals cos squared theta minus sine squared theta. So this is the version I'd like you to memorize. Here's our double angle for sine. And here's our double angle for cosine. With the Pythagorean identities, you could write this in many different ways. You could rewrite cos squared as 1 minus sine squared. You could rewrite sine squared as 1 minus cos squared. So there are many ways for us to rewrite this. But these are the 2 you want to remember. So add those to your collection. But I want to stick with these 4 identities because I also want to generate an identity for tangent of a plus b. So looking at the information we have here, that's going to be my goal, to generate an identity for tangent of a plus b. So how are we going to think of that? Well, tangent of a plus b is sine of a plus b divided by cosine of a plus b. Thanks, Ruben. I guess it's working. So 2 cos theta minus 2 sine theta, not quite, but you saw what my previous answer was, and I appreciate your participation. Tangent of a plus b is sine of a plus b divided by cosine of a plus b. So let's look at these formulas here. Sine of a plus b, sine a cos b. Minus cos a sine b. Over cos of a plus b, cos a cos b. Minus sine a sine b. Okay, that is a form for tangent of a plus b. So that's not wrong. But what we can do is we can make that look a little cleaner. And what I'm going to do is I'm going to divide both sides by something. Now, what is something that makes the most sense here? I think I'm going to divide top and bottom by cos a cos b. So divide the top by cos a cos b. Divide the bottom by cos a cos b. That's going to be our strategy here. So let me go ahead and scratch this equal sign. Divide the top by cos a cos b. So top I have sine a cos b minus cos a sine b. And I'm going to divide by cos a cos b. So divide the first guy by cos a cos b. Divide the second guy by cos a cos b. And then what are we going to do? All over cos a cos b minus sine a sine b. Cos a cos b minus sine a sine b. And you can see my goal is to do what? My goal, oh, you're telling me I made a mistake? Thank you, friends, in comments. Indeed, I made a mistake. That should be plus, so I appreciate that. Again, we're going to divide the bottom by cos a cos b, so let's do that. Divide the bottom by cos a cos b. Okay, so let's simplify this if we can. The cos b's cancel here. Sine a divided by cos a is what? Is tangent a. Plus, again, thank you for the correction, over here, the cos A and the cos A cancel, and I get sine B over cos B, which I believe is tangent B. And then what do we have? And then we have cos A cos B over cos A cos B. That's just 1 minus sine A over cos A is tangent A. Sine B over cos B is tangent B. So we were able to develop an identity for tangent A plus B. We could add that to our list that we had earlier. So we have the 2 for sine, we have the 2 for cosine. Let me quickly go ahead and give you the 2 for tangent. But I have to be honest with you, I do not have the tangent ones memorized. So what we just proved was tangent of A plus B equals tan A plus tan B divided by 1 minus tan A tan B. And similarly, we could have one for tangent of A minus tangent B. So that's proven the same way as the last one was, so I will give that to you as an exercise. Tangent of A minus B is tan A minus tan B. Over 1 plus tan A tan B. Now, generally speaking, whoops, see if I can show you all of those. There we go. Generally speaking, I'm not going to make you memorize those 6 forms. We'll give those to you on the exam. But again, once we get ourselves to calculus, I think it's a good idea to at least have these first 4 down, because that does come in handy. Okay, let's go ahead and build our chart of our favorite angles, and let's do some analysis with these identities. So we have these handy. So hopefully you'll be able to use them today as we look at some examples. So I like to have my chart ready to go. So let's do that. Take a look at our chart. Zero, 30, 45, 60, and 90. Just want sine, cosine, and tangent with radians. So next column is radians. So of course 0, pi over 6, pi over 4, pi over 3, pi over 2. Then we have sine. Sine of 0 is 0. Sine of pi over 6 is a half. 1 over root 2. Root 3 over 2. 1. Cosine, you just do it backwards. Cosine 1. Then root 3 over 2. Then 1 over root 2. Then a half. 0. And then tangent. 0 divided by 1 is 0. A half divided by root 3 over 2 is 1 over root 3. Something over itself is 1. This is root 3, and this is undefined. So you should really build this chart whenever you're starting these problems to make sure you have these numbers in mind. So let's assume we have those. And I want to do the following sorts of questions. So let's take a look at pi over 3 plus pi over 4. If we look at our chart, pi over 3 is 60 degrees, pi over 4 is 45 degrees. If we add them together, that's 105 degrees. That might be helpful for us to think about. But we also want to make sure that we can add these things. So how did I teach you how to add fractions? More often than not, if the denominators are relatively prime, this times this, pi times 4 is 4 pi, plus, max the sign, 3 times pi is 3 pi, over 3 times 4 is 12. So I get 7 pi over 12. And then I can ask the question, what is the sine of 7 pi over 12? What is the cosine of 7 pi over 12? Those are things we want to know. Well, we've just shown 7 pi over 12 is pi over 3 plus pi over 4. So this is the sine of pi over 3 plus pi over 4. Now we need to know our identity. What is our identity for sine of A plus B? You have it right there. Sine of A plus B, sine A cos B plus cos A sine B. Sine pi over 3, sine pi over 4 plus cos pi over 3, cos pi over 4. Sine pi over 3, sine pi over 4 plus cos pi over 3, cos pi over 4. And let's take a look. Pi over 3 is where? Sine of pi over 3 is root 3 over 2. Sine of pi over 4 is 1 over root 2. The notation here is bad. That's cos pi over 3. Cosine of pi over 3 is a half. Cos of pi over 4 is 1 over root 2. So you'll notice we have a common denominator here of 2 root 2. Root 3 times 1 is root 3 plus 1. So I get root 3 plus 1 over root 2, which is fine. There's many, many ways you can answer that, rationalizing the denominator and such. But I think I will stick with that one. Again, sine of A plus B, sine A, except that's wrong. Whoops. Let's fix it. Sine cos plus cosine. Let's fix that again. I apologize for that. Here's our formula, sine A cos B plus cos A sine B. Let me fix that right now. So again, the reminder, this is sine A cos B plus cos A sine B. So sine of pi over 3, as we said before, is root 3 over 2. Cos of pi over 4 is 1 over root 2. Cos of pi over 3 is a half. Sine of pi over 4 is 1 over root 2. So the number on the bottom is 2 root 2. The number on the top is root 3 plus 1. So that is fixed. The next example I have is cosine of 7 pi over 12. So if that's the case, what are we going to say? Cosine of 7 pi over 12 is cosine of pi over 3 plus pi over 4. Our formula for cosine, cos A cos B minus sine A sine B. Cos A cos B minus sine A sine B, that's what we need to use. So cos first, cos the second, equals cos pi over 3, cos pi over 4, minus sine pi over 3, sine pi over 4. And I hope I can get these right. Let's see, cosine of pi over 3. Cosine of pi over 3 is a half. Cosine of pi over 4 is 1 over root 2, minus the sine of pi over 3 is root 3 over 2, and the sine of pi over 4 is 1 over root 2. So we get 1 over root 2, 1 over 2 root 2, minus root 3 over 2 root 2, which I'm okay rewriting that as 1 minus root 3 over 2 root 2. Again, there are many, many, many other ways we could do this. So you've got to be careful in terms of looking at that. But that certainly is a correct answer. All right. Let's take a look at one more in that world. So let's take a look at the following. There we go. We're going to take a look at 5 pi over 6 plus 3 pi over 4. What is 5 pi over 6 plus 3 pi over 4? Let's get ourselves a common denominator, which would be 12. So multiply the bottom by 3 and the top by 3 on this side. Multiply the top by 2 and the bottom by 2 on that side. What does this give me? 2 times 5 pi. 10 pi over 12 plus 3 pi times 3, which is 9 pi over 12, which gives me 19 pi over 12. And let's say for the discussion, we want to do sine again. Let's do sine of 19 pi over 12. And that's going to give me the same thing as the sine of 5 pi over 6 plus 3 pi over 4. And what is our rule for sine? Sine of a plus b, sine a, so sine of 5 pi over 6, cos b, cos 3 pi over 4, plus cos a, cos 5 pi over 6, sine b, sine 3 pi over 4. So let's write all that down. Sine cos plus cos sine. Sine of 5 pi over 6, cos 3 pi over 4, plus sine cos plus cosine 5 pi over 6 sine 3 pi over 4. Sine cos plus cosine. So this is what we have. We have to think about where these things are now. So where is 5 pi over 6? Where is 3 pi over 4? Well, 5 pi over 6 is not quite pi, so that's pi over 6 short of pi. So sine of 5 pi over 6 is in quadrant 2, so that's plus the sine of pi over 6, which is 1/2. Next I have what? Next I have cosine of 3 pi over 4. Where's 3 pi over 4? It's in second quadrant. Reference angle is pi over 4. So the cos of 3 pi over 4, that's in the second quadrant, so that's negative. Reference angle is pi over 4. Negative the cos of pi over 4, which is negative 1 over the square root of 2. Cosine of 5 pi over 6. Okay, well, that's the next thing that we have. So here's our 5 pi over 6 again. So cosine of 5 pi over 6. So pi over 6 short of pi. That's negative. Cosine is negative in that quadrant. Negative cosine of pi over 6, which is negative root 3 over 2. And then we're finishing this off with the sine of 3 pi over 4, again, which is there. So that's pi over 4. Second quadrant sine is positive. Sine of 3 pi over 4 is the positive, the reference angle, sine of pi over 4, which is positive 1 over root 2. I hope I've done all those correctly. There's a lot of computation involved, but I would assume you'll tell me if that is not the case. All right, let's go ahead and finish this off. You'll notice 19 pi over 12 is beyond 12 pi over 12, so this is not in the first or second quadrant. So we know it's going to be negative. So I guess we shouldn't be surprised that I get negative 1 over 2 root 2 plus negative root 3 over 2 root 2, which I will write as negative 1 minus root 3 over 2 root 2. Okay. So pretty good in terms of how we use that. Again, sine of a plus b is sine a cos b plus cos a sine b. All right. Let's go to our next set of problems. This one I would like you to do using our various rules, and I want you to post your answer in the comments. So I'd like you to try this one, please. Cosine of 70 degrees, cosine of 20 degrees, minus sine of 70 degrees, sine of 20 degrees. If you want to see the formulas, I've got a version of them here. But go ahead and give the answer, construct the answer, and post it on the comments. Go. If you need a hint, I will point you in the direction of this identity. That's what we want to use. Can you get an answer for the question? Do we have a brave student who will post? Are there any brave students out there? Hey, thank you. That's pretty good. Cos of 90, we see, and cos of 70 plus 20, very good. Do we know what the cosine of 90 degrees is? We look at our unit circle. Our unit circle is here. Here's 90 degrees. The x value is 0. The y value is 1. So at 90 degrees, cosine of 90 is 0. And sine of 90 degrees is 1. So very good. So the answer to this is 0. So what I'll do is I'll write the formula down again. So we've got cosine of a plus b. Cosine of a plus b is cos a cos b minus sine a sine b. This is the identity we're using. Cosine a is 70, b is 20. That's what you guys saw on the comments. Minus sine a, sine 70, sine 20. This has got to be what? Cosine 70 plus 20 degrees, which in turn equals cos 90 degrees, which in turn equals 0. So the answer to all of that is 0. Let me go ahead and give you a similar one in that vein. See if you can do this one. Again, if you can post the answer online, that would be great. Sine 7 pi over 12, excuse me, sine pi over 12, cosine 7 pi over 12. And it's cosine pi over 12, sine 7 pi over 12. And again, I would assume you want to see those identities just to make it easier to locate it. So here is one version. So try that. If you can, please post your answer online. See what you get. You hint for this one, sine cos minus cos sine. This is the identity you need to use. That might be helpful. Maybe I'll write it down for you underneath the problem. Sine of a minus b equals sine a cos b minus cos a sine b. Zoe has an answer. Ruben has a pretty good answer, just not simplified, but I like them both. So very good. Going ahead and plugging these things in, we have sine of pi over 12 cosine 7 pi over 12 minus cosine pi over 12 sine 7 pi over 12. That's what we're given in the problem. And this has got to be sine pi over 12 minus 7 pi over 12. And Ruben saw that that was sine negative 6 pi over 12. So this equals sine negative 6 pi over 12, which is sine negative pi over 2. And what is that? Let's look at our unit circle for that. Sine of negative pi over 2. Negative pi over 2 is down here. The x value is 0. The y value is negative 1. Sine is the y value. So my answer for the sine of negative pi over 2 is negative 1. Okay. All right. Let's take a look at an identity I want to prove. So again, maybe I'll let you guys try this. Zoe asked a question earlier on the board about sine theta plus theta. So let's address that now, and then I will let you guys try the following problem. So here is our rule. Our rule is sine of a plus b is sine a cos b plus cos a sine b. And what I want is I want a to be theta and I want b to be theta. Just one more time. So if a is theta plus b is theta. Now I have sine theta plus theta is equal to what? Sine theta cos theta plus cos theta sine theta. The left-hand side, sine of theta plus theta. Sine of 2 theta is sine cos plus cos sine. That's 2 sine theta cos theta. So that's how we prove that double angle identity for sine. What I would like you to do using this same identity, please, I would like you to prove the following. Prove that sine of pi plus theta, prove sine of pi plus theta equals negative sine theta. So let me give you a minute to play with that, then we'll take a look at it together. This is the identity you want to use. Don't forget your unit circle. See if you can get there. So you're going to want pi to stand in for A. You're going to want theta to stand in for B. Hopefully you're making some progress. Sine of A plus B is sine A cos B plus cos A sine B. Instead of A, I'm going to use pi. Wherever I see A, I'm going to replace it with pi. And wherever I see B, I'm going to replace it with theta. That's the process that we're using here. So this will be sine A, that's sine what is A is pi. Cos what is B, that's cos of theta, plus cos of A, what is A is pi. Sine of B, what is B, sine of theta. Now the question is, what is the sine of pi and what is the cos of pi? Let's look at our unit circle. Our unit circle is over here. Here's pi. The x value is -1. The y value is 0. So from there, we can say cosine of pi is -1. Sine of pi is 0. So what does sine of pi plus theta equal? Sine of pi is 0. Cos of theta, so 0 times cos of theta, plus cosine of pi. What is cosine of pi? Cosine of pi is -1 times sine of theta. What is sine of theta? Sine of theta is sine of theta. So what I get is I get 0 minus sine theta. I get negative sine theta. And negative sine theta, of course, is, can't read it. Negative sine theta, of course, is my right-hand side. So we have successfully proven this identity. Okay, so we start with left-hand side here. Left-hand side is here. Equals sine of pi plus theta equals that, equals that, equals that, equals that, equals that. Right-hand side, and we're good. All right, I have one last proof I want to do for you in today's lesson, so let's get to it. So we're going to, again, go back and use our sine of A plus B identity. So I will keep that up on the screen so I can maintain it, so I can see it. And well, here's what I want to try to prove, and maybe I'll let you guys do it for a minute first, see if you can get there. Sine of A plus B. Sine of parentheses A plus B, be careful how you say that, I guess, divided by cos A cos B equals tangent A plus tangent B. Whoops. So take a minute to try that, and there is the identity that you want to use to help you with that. So see if you can make some progress with that one. We'll take a look at it together here in a minute. Replace sine A plus B with that. Sine A cos B plus cos A sine B. Divide everything by cos A cos B, and hopefully your result will be tangent A plus tangent B. I hope you're making progress. So let's do it. Left-hand side is what I have here. Sine A plus B over cos A cos B. What is sine A plus B? I have my rule up there, sine A cos B plus cos A sine B divided by cos A cos B. What you have to recognize here is that I have a common denominator, so I could break it up into two fractions, each over cos A cos B. So I could say sine A cos B over cos A cos B over the common denominator plus cos A sine B over cos A cos B. Do I have some cancellations? I think so. The cos B's go away here. And I have sine A divided by cos A, which is tangent A, plus on this side, the cos A's go away. And I get sine B over cos B, which is tangent B. That's my right-hand side equals right-hand side. And that's my answer. All right, so the main topics we talked about today were how you do a proof, like we did here. Start on the left-hand side, a string of equals to get to the right-hand side. We talked about the four identities that we want to use: sine of A plus B, sine of A minus B, cos of A plus B, cos of A minus B, right? So these were important for us. And then we also developed the rules for tangent A plus B, tangent A minus B, as well as our double angle identities we did here. Our double angle identities, sine of 2 theta, cos of 2 theta. So those were our main topics of today's lecture. Based on the fact that the TAs are not negotiating until Friday, I have to assume that we will not be meeting discussion sections on Thursday. I also have to assume that I'm not going to ask you to cross picket lines, so we'll do another video lecture for Friday's lesson. I am planning to go live on Thursday night since I have a conference on Friday. If you're able to join me on Thursday night at 7:30 for the live lecture, I would appreciate that. If not, of course, you can watch it at your earliest convenience. All right, my friends, thank you so much for your time. Good luck with your studying, and I will talk to you virtually Thursday night, and you can watch me anytime over the weekend. Ciao.